Hey folks, I'm going to make some short videos for you. I need you to add some things to your notes that we were doing in section 1, right? So I'm going to have you put down section 2 now. So you probably have, let's see if I can do this here. You probably have 6.1 up here as well. 6.1 was past couple days. We talked about radians, angles, and standard position, all that kind of stuff. But anyways, put down 6.2 day 2 and see what you can add to these notes. So it might need to go vertically if you have space in your notebook. If you don't, you may need to start a new page. So the first thing I want to start with is in nature, in biology, all kinds of places, geometric shapes are seen. So, one application is just understanding our natural world. But maybe as important, we're just trying to get a little bit smarter. Okay, we're trying to use these topics to understand mathematics at a deep level. So what do we got going on here? We've got a crystal here that has symmetry, has radial symmetry. We can rotate it 60 degrees and it's going to land right back on top of itself. I want to try to make that super clear here. So let's see if I can draw a triangle just right here between here, and then I'm going to go straight across that way. Okay, so you can see there's 1, 2, 3, 4, 5, 6 branches, if you will, to this crystal, and they're all symmetric, like it's rotating the same amount. So if I took 360 and I divide it by 6, I get 60 degrees, right? So this central angle is 60 degrees. This radius is equal to this radius, because you can see I drew a circle around this thing. And if these two are equal, the base angles are equal, right? So, well, if this is 60, we have 120 left, so this has to be an equilateral triangle. So I'm trying to do some math reasoning here that would leave no doubt in people's minds, like a little proof, right? You might have said, I don't need that proof. I saw that it was an equilateral triangle right from the beginning. That's great, but I'm just trying to be as mathematical or mathematically correct as I can. So if I draw an altitude right here and bisect, perpendicularly bisect, it's going to perpendicularly bisect this side over here. Well, think about that for a second. Let's just say this side right here was 1 long, okay? The radius, I'm going to put an R out here for radius, is 1 long. Well, what would that make this side right over here? I mean, if this side, we said it was an equilateral triangle a second ago, if we said this side was 1 and we just drew in a altitude, perpendicular bisector to this side, well, bisector means it goes right to the midpoint. So this would be 1/2 of whatever this side was, right? Because, well, whatever this side is. So that's got to be 1/2, right? Because, we cut the 1 in 2 equal parts. Now, I hope I'm making that part clear. The next part's going to be a little tricky. We're going to use Pythagorean theorem to find this side right over here. So let me go back to yellow first. Well, now let me put it in red. This side is going to be a little trickier. So, like, warning, alert, red, it's code red. So x squared, what I'm saying is the half was hopefully not hard to see. Hopefully I made that super clear. Like, of course, that's a half. And so we've got plus a half squared. I'm doing Pythagorean theorem right now. And then I get 1 squared on this side. Okay, so we get x squared plus 1/2 times 1/2 is 1/4. And then I've got 1 squared is 1 on this side. Now, if I subtract 1/4 from both sides, I have 3/4 on the right side, and on the left side, I got x squared. If I take the square root of both sides, I get the square root of 3/4. We learned probably in integrated 2, you may have forgotten this, that it's kind of bad to have square root, like this is the same as the square root of 3 over the square root of 4. So we always try to simplify the denominator if we can, like take the square root of it. In this case, we're lucky because 4 is a perfect square. The square root of 4 is 2. So I just get plain old 2 down in the denominator. Hey, that's going to be really, really important for what we're dealing with. This side right here is the square root of 3 over 2. Let me explain why that's so important. Okay, I'm going to zoom back out. Let's go back over here. Do you remember how we took this 30, 60, 90 triangle right there, and I flipped it around? You know, I did this. I said, let's flip it like this, and then let's put it so that it is just in the perfect spot. I'm not sure what happened to my circle. Something changed its size. It doesn't seem to be fitting just perfectly. So here's the center, you know, there's the origin. Remember, we have to, oh, maybe my triangle was okay the way it was before. Hold on one sec here. Let's go back to normal size like that, because it does look like if I put it right here and we draw in a y-axis, it does look like that's going to go right through the center of my circle. And then if I draw an x-axis in there, okay, so we got an x and we got a y-axis. Well, we just said that the hypotenuse is 1. We're in the unit circle, right? You notice how it goes from the origin out to the circle. That's called the radius. The radius equals 1. This short leg over here, you remember how, let's zoom out one more time and go look at that again. Do you remember how we had drew in this, we drew the altitude, and that splits that 60-degree angle right here, it splits it in half. So we're going to have 30 degrees right here, and we're going to have 30 degrees right here. So across from the 30-degree angle, this side right over here is the one that we have. I'll zoom back out here in just a second. I call this thing right here the short leg. So add that to your notes right now, short leg. Okay, so let's go back over to our drawing up here, and you'll see that, hey, look, across from the 30-degree angle is the short leg. So here we go. This is 1/2, because remember how it was 1/2 of the hypotenuse? So it was, if this was 1, this is 1/2. If this was 10, this would be 5. If this was 20, this would be 10. So then we did Pythagorean theorem down there in our work. You can still see the remnants of it. And we ended up with the square root of 3 over 2 on this side. What does that mean about the coordinates right over here? Well, I'm coming over a certain amount and I'm going up a certain amount. So this is going to be the square root of 3 over 2. And this next one is 1/2. Okay? So we're going to finish slides 1 through 3, and then we're going to have a little discussion. Thanks for watching my video.